Hari Om. Hello everyone, I am Sri Jyoti. Welcome to my channel. Today's video is complex numbers and quadratic equations part 3. So make sure that you have watched part 1 and part 2. Today we are going through polar form of a complex number. A complex number x plus iy corresponds to the ordered pair xy in a xy plane. That means real part of a complex number representing in x-axis and imaginary part of a complex number representing in y-axis. So that x-axis in this plane, x-axis is called real axis and y-axis is called imaginary axis. It is the point xy, so that this distance is nothing but y and it is x. Since it is a right angle triangle, by Pythagoras theorem, it is nothing but square root of x square plus y square, isn't it? See, it is nothing but distance from origin to the point, therefore it is the modulus of r. That is, if it is r, it is called modulus of r. That is square root of x square plus y square. So here, since it is a right angle triangle, we can write, okay, let theta be the angle from x-axis to the ray, okay. So sin theta, this theta is called argument of the complex number, okay. Since it is a complex number, then we representing complex number in a plane, that plane is called argand plane, okay. So here sin theta, here theta is called the argument of the complex number. So let us see what is sin theta. Sin theta is opposite divided by hypotenuse, that is nothing but y divided by r. Okay. So r is equal to square root of x square plus y square. So it is the distance from origin to the point. That is the modulus of a complex number. It's a complex number, right? We represented a complex number in xy plane. Okay. So it is the argand plane. Okay. Here representing real part in x-axis and imaginary part in y-axis. Okay, so here sin theta, okay, this theta is called the argument of the complex number. Sin theta is equal to y by r. Why? Because since it is a right angle triangle, we can apply Pythagoras theorem. Okay, sin theta is equal to opposite side divided by hypotenuse, that is y divided by r. So what about cos theta? Cos theta is adjacent side divided by hypotenuse, that is x divided by r. That implies y is equal to take r left side, so we will get r sin theta. Okay, that implies x is equal to r cos theta. Okay, so we can write the complex number x plus iy as, what is the value of x? What is x? X is r cos theta plus I. What is y? Y is nothing but r sin theta. So here r is common on both sides. Let us take it out. So r into cos theta plus I sin theta. Okay. So here, see, it is the polar form of a complex number. Here r is the modulus of a complex number and theta is the argument of a complex number. It's very important. See, we will be asked to find modulus and argument of a given complex number. Okay, so remember, polar form of a complex number is r into cos theta plus I sin theta. R is nothing but modulus of a complex number, that is square root of x square plus y square, and theta is the argument of a complex number. Now let us solve some problems. Find the modulus and the arguments of given complex numbers. First one, given complex number is z is equal to -1 minus I root 3. See, first step, we will write this one, -1 minus I root 3, and write the polar form of a complex number. Polar form of a complex number is r into cos theta plus I sin theta. Then comparing on both sides with real part and imaginary part. Okay, corresponding parts, that is minus 1 is equal to r cos theta and minus root 3 is equal to r sin theta. Okay, on squaring and adding, okay, by squaring and adding we will get r square cos square theta plus r square sin square theta is equal to, take its square and add, so minus 1 square plus minus root 3 square. Okay, r square is common, take it out. So r square into cos square theta plus sin square theta, that is equal to 1 plus minus root 3 square, that is 3. So r square cos square theta plus sin square theta is nothing but 1, that is first identity of the trigonometric function. So r square into 1, that is equal to 4. This implies r is equal to 2. Okay, if r square is equal to 4, r is equal to plus or minus 2. Minus 2 is impossible because r is the distance from the origin to the point. So r is equal to 2. What is r? R is nothing but modulus of a complex number, right? That is, see, we have to find the modulus and the arguments. So modulus means r and arguments we have to find theta. Okay, so we have found r modulus of a complex number, that is r is equal to 2, and next we have to find arguments of given complex number. First we will find the argument of this complex number. So that we will write r cos theta, that is equal to minus 1. So what is the value of r? That is 2. So 2 cos theta is equal to minus 1. We have to find the theta value. So here 2 sin theta is equal to minus root 3. Substituted r values in these equations. So here we will get cos theta is equal to minus 1 by 2. Sin theta is equal to minus root 3 by 2. Okay. See, when cos is 1 by 2, when sine is root 3 by 2. Sin pi by 3, sorry, cos pi by 3 is 1 by 2. Isn't it? Cos pi by 3. Cos pi by 3 is 1 by 2. And sin pi by 3 is root 3 by 2. Okay. Then, here we have got the sine and cosine values are negative. Okay. Where sine and cos are negative? In third quadrant. In first quadrant, sine positive. In second quadrant, in first quadrant, all are positive. In second quadrant, sine positive. In third quadrant, sine and cos are negative. Only tan positive, right? So that we can write it as theta is equal to, okay, it is negative and the value angle is pi by 3. So that we can write theta is equal to pi plus, because it is in third quadrant. Suppose it is the unit circle. Okay. So here it is pi by 2, pi is 0, 3 pi by 2. Okay. So in third quadrant means it lies in pi plus. So that we can write pi plus. So here pi plus pi by 3. Okay. That is theta is equal to pi plus pi by 3. Why? Because see, sine of pi plus pi by 3. Pi plus, okay, in third quadrant. So in third quadrant sine is positive, negative. Therefore we can write minus sine pi by 3. Okay. Therefore sine pi by 3 is nothing but root 3 by 2. So minus root 3 by 2 we will get. Isn't it? So here we can write the thetas. In same way we can write cos. See, cos pi plus pi by 3, that is nothing but minus cos pi by 3. Why? Because in third quadrant cos is also negative. Okay. So pi plus pi by 3. If it is pi, the sine will become sine itself. Okay. Cos become cos itself. Right. So cos minus cos pi by 3. That is minus cos pi by 3. Cos pi by 3 is 1 by 2. So minus 1 by 2. So we will get theta is equal to pi plus pi by 3. That is 3 into pi, 3 pi, 4 pi by 3. Okay, so theta value is 4 pi by 3. That is argument of given first this complex number is 4 pi by 3. Okay, now let us go to second one. Second one, z is equal to minus 1 plus I. So here, let us write, compare this with polar form of a complex number. Minus 1 plus I is equal to r into cos theta plus I sin theta. Okay, then comparing real parts and imaginary parts. So that we will get r cos theta is equal to minus 1, r sin theta is equal to 1. By squaring and adding, we will get r square cos square theta plus r square sin square theta is equal to minus 1 square 1, 1 square 1, 1 plus 1, 2. Okay. So here r square is common on both sides. So let us take it out. So r square into cos square theta plus sin square theta is equal to 2. Since sin square theta plus cos square theta is 1, r square into 1 is equal to 2. This implies r is equal to root 2. Here we will get, here we have got modulus of given complex number. Okay, that is r is equal to root 2. So next we will find the argument of a complex number, that is theta, by substituting r is equal to root 2 in these two equations. So root 2 cos theta is equal to 1, root 2 sin theta is equal to 1. It is minus 1. Okay. Then what is cos theta? That is cos theta is equal to minus 1 by root 2 and sin theta is equal to 1 by root 2. Okay. See here, where is cos is 1 by root 2? Cos pi by 4 is 1 by root 2 and sin pi by 4 is 1 by root 2. Okay, then look at the sign. Cos theta is equal to minus 1 by root 2. So in which quadrant cos is negative? We know that in second quadrant and third quadrant cos is negative, and in which quadrant sin is positive? In second quadrant. Only second quadrant sin is positive. Therefore, here this theta lying in second quadrant. Why? Because in second quadrant cos is negative and sin is positive. Okay. Here we have got cos value negative and sin value positive. So therefore theta lies in second quadrant. Okay. In second quadrant sin is positive and cos is negative. Therefore we can write, see our angle is pi by 4. We know that cos pi by 4 is 1 by root 2 and sin pi by 4 is 1 by root 2. Therefore our angle is, standard angle is pi by 4. Then next, what is the value of theta? And after sin, see, it is cos is minus 1 by root 2, sin is plus 1 by root 2. So theta lies in second quadrant. Therefore we can write theta is equal to pi minus pi by 4. Okay, pi minus, in second quadrant pi minus pi by 4, that is 3 pi by 4. Okay, so therefore theta value is 3 pi by 4. Therefore argument of given complex number minus 1 plus I is 3 pi by 4. Third one, z is equal to root 3 plus I. So first we will write this with polar form of a complex number. Root 3 plus I is equal to r into cos theta plus I r sin theta. Sorry, we have taken r outside. So cos theta plus I sin theta. Okay. Then compare this with real parts and imaginary parts. So that we will get r cos theta is equal to root 3. Okay, comparing corresponding sides, that is root 3 real part. Here r cos theta is the real part of this complex number. So r cos theta is equal to root 3. R sin theta is equal to 1. Then by squaring and adding we will get r square cos square theta plus r square sin square theta is equal to root 3 square 3 plus 1 square 1, that is equal to 4. So r square is common. Take it out. So no need to write one more step. Okay. So here after taking r square outside, so we will get r square into cos square theta plus sin square theta, that is 1. So r square is equal to 4, that implies r is equal to 2. Okay. So we have got modulus of a given complex number root 3 plus 1i is 2. Okay. Next we will find the value of theta, that is argument of a given complex number. So by substituting r is equal to 2 in these equations, that is 2 cos theta is equal to root 3, 2 sin theta is equal to 1. That is cos theta is equal to root 3 by 2, sin theta is equal to 1 by 2. Okay. See here, look at the sign, all are positive, so it lies in first quadrant. And what is the angle? See, when cos is root 3 by 2, when sin is 1 by 2, pi by 6, right? That is 30 degree. Okay, sin 30 is 1 by 2, sin cos 30 is root 3 by 2, that is pi by 6. So here directly we can write theta is equal to pi by 6. Because it lies in first quadrant, no need to check the sign. Okay, so cos theta and sin theta are positive, therefore it lies in first quadrant. So directly we can write theta is equal to pi by 6. Sin pi by 6 is 1 by 2, cos pi by 6 is root 3 by 2. Therefore, argument of a given complex number root 3 plus I is pi by 6. Now how can we write it in polar form? Let us see. Here polar form given complex number is r is nothing but 2 into cos pi by 6 plus I sin pi by 6. Okay, it is the polar form of a given complex number. See, if you are asked to write the polar form of a given complex number, at last you have to write this one. Okay, after finding modulus and theta value, you have to write this one, that is given complex number is equal to polar form. R into, right, substitute R value and theta value. Okay. Now let us solve some quadratic equations. First one, x square plus 3x plus 5 is equal to 0. Here x is equal to, apply the formula, minus b plus or minus square root of b square minus 4ac divided by 2a. A is the coefficient of x square, b coefficient of x, c is constant term. Okay. Then next apply. Minus b, that is minus 3 plus or minus square root of b square 9, okay, 3 square, minus 4 into a is 1 into c is 5, divided by 2 into a is 1. Okay, then minus 3 plus or minus square root of 9 minus 20, okay, 9 minus 4 into 5, 20, that is minus 11, divided by 2. That is equal to minus 3 plus or minus, see here you have got square root of minus 11. Okay, so it's a complex number. So we can write square root of minus 11 as square root of minus 1 into square root of 11. Isn't it? That is square root of a into b is nothing but square root of a into square root of b. So like that, here we can write square root of minus 11 as square root of minus 1 into square root of 11. Okay. So square root of minus 1 into square root of 11 divided by 2. That is equal to minus 3 plus or minus, see here we can write what is the square root of minus 1. See, in previous classes you did not study what is the what we will get after getting minus, square root of minus. So you studied about the real numbers, right? So here we know what is the square root of minus 1. So we can apply the value. Okay, square root of minus 1 is nothing but I, that is imaginary number. So here minus 3 plus or minus I root 11 divided by 2. Okay, so what is the solution? That is x value values are minus 3 plus I root 11 divided by 2, and one more minus 3 minus I root 11 divided by 2. Okay. Next one, x square plus x plus 1 by root 2 is equal to 0. So first of all we will write the formula. X is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Now substitute ABC values, that is x is equal to minus b coefficient of x 1, okay, plus or minus square root of b square 1 itself minus 4 into a coefficient of x square 1 into c constant term 1 by root 2 divided by 2 into a is nothing but coefficient of x square 1. That is equal to minus 1 plus or minus square root of 1 minus 4 divided by root 2. 4 is nothing but 2 into 2. So 1 root 2 will cancel. 2 into 2 divided by root 2. 2 is nothing but root 2 into root 2 into 2 divided by root 2. So 1 root 2 will cancel. So remaining 2 root 2. Okay. Divided by 2. Then minus 1 plus or minus, here it is the larger value, right? It is greater than this one, 1. Okay. So 2 root 2 is greater than 1. Therefore, we will get it is minus value. So here we can write minus root minus 1 outside. Okay. So root square root of minus 1 into, okay, minus 1. We have taken minus outside. So it will be minus plus 2 root 2, okay, divided by 2. That is minus 1 plus or minus square root of minus 1 is nothing but I square root of 2 root 2 minus 1 divided by 2. Okay. So solutions are minus 1 plus I root 2 root 2 minus 1 divided by 2. Minus 1 minus I root 2 minus 1 divided by 2. Okay. Now let us go through this question. Convert given complex number in the polar form. Given complex number is z is equal to 1 plus 3i divided by 1 minus 2i. See here, before converting this complex number in the polar form, first of all we have to make it in the form of a plus ib. Okay. So here given complex number 1 plus 3i divided by 1 minus 12. So how to make it in the form of a plus ib? By multiply and divide by conjugate of 1 minus 12, that is denominator of this given complex number. Okay, that is into 1 plus 3i divided by 1 minus 2i into 1 plus 2i conjugate of denominator, that is conjugate of 1 minus 2i. Conjugating means changing the sign of imaginary part. Okay, so 1 minus 2i, so multiply and divide by 1 plus 2i. So 1 plus 3i divided by 1 minus 2i into 1 plus 2i divided by 1 plus 2i. Okay, so that we will get here a real number in denominator. That is equal to 1 plus, okay, let us simplify this one. 1 into 1, 1 plus 1 into 2i, 2i plus 3i into 1, 3i plus 3i into 2i, 6i square divided by, here now it is in the form of a plus b into a minus b, a minus b into a plus b. That is nothing but a square minus b square, right? That is a is 1, okay, 1 square 1 minus b square, b is nothing but 2i, so 4i square, okay, that is equal to 1, 2i plus 3i, 5i, 6i square, I square value is minus 1, so 6 into minus 1 minus 6 divided by, here 1, I square is minus 1, so minus minus become plus, so this will become plus 1 plus 4. That is equal to 1 minus 6 is minus 5 plus 5i divided by 5. That is, now let us write it in the form of a plus ib, complex number a plus ib. So minus 5 divided by 5 plus 5 divided by 5i. Okay, that is minus 1 plus i. See, now we have got a complex number in the form of a plus ib. Now we can convert it into the polar form. Okay, so how to convert? First we will write, okay, minus 1 plus I, that is equal to, our polar form of a complex number is r into cos theta plus I sin theta. Okay, so to write it in the form of polar form, we have to find r value and theta value. Okay, now compare this with real parts and imaginary parts. So r cos theta is equal to minus 1, r sin theta is equal to 1. Okay, then by squaring and adding we will get r square cos square theta plus r square sin square theta is equal to minus 1 square 1 plus 1 square 1 itself, that is equal to 2. Okay, here r square is common, take it out. R square into cos square theta plus sin square theta is 1, so r square is equal to 2, that implies r is equal to root 2. Okay, now we have got r value. Next we need to find theta value. Okay, then only we can write given this complex number into polar form. Okay, so next we will find theta value. So for that we will substitute r value in, okay, r cos theta is equal to minus 1, r sin theta is equal to 1. Okay, let us substitute r value here. So root 2 cos theta is equal to minus 1 and root 2 sin theta is equal to 1. That is, cos theta is equal to minus 1 by root 2, sin theta is equal to 1 by root 2. Okay, see here, when cos is 1 by root 2, when cos is 1 by root 2, cos pi by 4 is 1 by root 2, sin pi by 4 is 1 by root 2. Okay, pi by 4. Then look at the sign. Cos negative and the sign value is positive. Where cos is negative? In second quadrant. In second quadrant, cos is negative and sin is positive, isn't it? In second quadrant, cos is negative, sin is positive. So here see, we have got cos value is negative and sin value is positive. Therefore theta lies in second quadrant. Okay, because in second quadrant sin is positive and cos is negative. Therefore we can write theta is equal to pi minus, okay, in second quadrant. If it is third quadrant, we can write pi plus. Okay, so pi minus pi by 4, that is 3 pi by 4. Okay, theta is equal to 3 pi by 4. Then now let us substitute here. So what is our polar form? 1 plus 3i divided by 1 minus 2i, given complex number, that is equal to r into cos theta plus I sin theta. Now substitute r and theta values. That is root 2 into cos 3 pi by 4 plus sin 3 pi by 4. It is the given polar form of a given complex number. Okay, root 2 into cos 3 pi by 4 plus sin 3 pi by 4. That's all. Next question. If a plus ib is equal to x plus I whole square divided by 2x square plus 1, prove that a square plus b square is equal to x square plus 1 whole square divided by 2x square plus 1 whole square. Okay, now let us take this one. A a plus ib is equal to x plus I whole square divided by 2x square plus 1. Okay, let us simplify this one, expand this one. So x square plus 2xi plus I square divided by 2x square plus 1. That is equal to x square plus I 2x. Here I square is minus 1 divided by 2x square plus 1. Okay. Now we can write it in the form of a plus ib. That is equal to x square minus 1 is real part. Okay. Divided by 2x square plus 1. It is the real part. Plus I 2x divided by 2x square plus 1. It is the imaginary part. In left side, in LHS a plus ib. Now comparing on both sides. Okay. Here a is equal to x square minus 1 divided by 2x square plus 1. Okay. Real part of this complex number is a, and right side real part of complex number is x square minus 1 divided by 2x square plus 1. So therefore a is equal to x square minus 1 divided by 2x square plus 1, and b is equal to 2x divided by 2x square plus 1. Okay. See, now we have got a and b. Next let us write a square. What is a square? Because in our C, what we have to prove? A square plus b square, right? So let us find what is a square and what is b square. Okay. A square is equal to x square minus 1 whole square divided by 2x square plus 1 whole square, right? B square is equal to 4x square, okay, 2x whole square, 4x square divided by 2x plus 1 whole square. Now what is a square plus b square? Let us see. X square minus 1 whole square, simplify, okay, x square is x raised to 4 minus 2x square, okay, a minus b whole square, a square minus 2ab plus b square plus 1, okay, divided by here 2x square plus 1 whole square. Okay. No need to expand this one because see here RHS 2x square plus 1 whole square is there. Okay. So next plus here 4x square divided by 2x plus 1 whole square. See, denominators are same, therefore we can add directly, that is x raised to 4 minus 2x square plus 1 plus 4x square divided by 2x plus 1 whole square. That is x raised to 4 here minus 2x square plus 4x square, that is plus 2x square. Okay, minus 2 plus 4 plus 2. So plus 2x square here, next plus 1 divided by denominator is 2x plus 1 whole square. 2x square, okay, 2x square plus 1. Yes, 2x square plus 1. Okay, now what is this one? See, it is nothing but x square plus 1 whole square, a plus b whole square. See what we will get, x square plus 1 whole square, a square, that is x raised to 4 plus 2ab, that is 2x square plus b square, that is 1. Okay. Therefore here x square plus 1 whole square divided by 2x square plus 1 whole square. Hence it is proved.